Welcome back to The Explainer, everyone. Today, we're tackling something that is just, well, it's literally colossal. We are looking at modern shipbuilding. You know, when you see those skyscraper-sized cargo ships or massive ocean liners, it's honestly hard to even wrap your head around how human beings managed to build something that big. But today, we're going to break down the sheer engineering strategy behind it all, focusing heavily on prefabrication and 2D subassembly.
Now, to really grasp the scale here, I want you to just picture a flat steel panel, we're talking roughly the size of an entire basketball court, rolling off a fabrication line. It's a single, massive, totally rigid structural unit. But here's the crazy part. Just 2 hours earlier, that exact same panel arrived at the start of the line as nothing more than a stack of loose, individual steel plates. In literally 2 hours, raw steel transforms into a primary building block of a super vessel.
And that rapid turnaround really captures our core thesis for today. There's a quote from our source material that just hits the nail on the head. The ship is not built plate by plate. It is built panel by panel, block by block. You see, building a megaship at an industrial scale, it's just not going to happen if you're out there trying to weld one tiny piece of steel at a time in the open air. Prefabrication is the absolute game changer that makes building these oceanic giants highly efficient and, honestly, even possible.
All right, let's kick things off with Section 1, the prefabrication strategy.
So why did shipbuilders universally switch to prefabrication? Well, think about the old-school traditional slipway method. You had workers outside, exposed to the rain, the wind, the freezing cold, building the ship piece by piece right on the inclined berth. They're doing awkward, exhausting overhead welding and hauling heavy equipment absolutely everywhere. It was rough. But with modern prefabrication, the ship is built in subunits, panels, blocks, modules, inside a fully climate-controlled covered workshop. Instead of awkward overhead angles, the welding is done flat. It's downhand. And because it's a controlled environment, the welding is way faster, the quality is massively improved, and, crucially, it can be automated.
Moving right along to Section 2, flat plate panel fabrication.
Let's virtually step onto the factory floor and see how this basic 2D subassembly, the flat plate panel, actually comes together. It's a really elegant step-by-step process. First, individual plates that have already been flattened, cleaned, and primed are laid out side by side on a massive assembly table. Next, workers tack weld them. Tack welding is basically just a series of small temporary welds to lock the plates into their exact position so nothing shifts around. And then, once everything is perfectly aligned, the heavy automated welding finally begins along the seams between those adjacent plates.
Which brings us perfectly to Section 3, submerged arc welding.
If we zoom in on that final seam welding step, the technology is just fascinating. Actually, if you were standing right next to the machine, it's highly counterintuitive because you can't even see the welding arc. Submerged arc welding is an automated process where the arc is completely buried under a thick blanket of white granular flux. Think of this flux as a kind of magic shield. It completely covers the molten weld pool, protecting that superreactive liquid metal from the oxygen and atmosphere in the room. The result? Extremely clean, insanely high-quality welds. But here is the real kicker with this tech. Because this process is highly automated and heavily protected by that flux shield, it hits deposition rates 5 to 10 times faster than a human being doing manual welding. 5 to 10 times. I mean, that is a massive leap in productivity. It's exactly why that basketball court-sized panel can be fused together in a fraction of the time it would take a whole crew of welders working by hand.
All right, on to Section 4, attaching panel stiffeners.
So, moving forward in our timeline, we now have this massive, perfectly welded flat sheet of steel. But there's a problem. It's floppy. A flat sheet of steel just doesn't have the structural rigidity you need for a ship's hull. It needs a skeleton. Enter the stiffeners. Longitudinal stiffeners, which are usually heavy steel profiles like bull flat bars or T-sections, are positioned right across the face of the panel. And to attach them, shipbuilders bring in a really cool specialized tool called a fillet welding tractor. It's essentially a small automated machine that just runs directly along the track of the stiffener, laying down precise welds.
Now, the most crucial part of this tractor is that it operates simultaneously. It doesn't weld one side and then loop back around to do the other. No, it makes the fillet welds on both sides of the stiffener at the exact same time. Why does that matter? Heat distribution. By applying heat and fusing both sides at once, it stops the metal from warping or distorting. So what you get at the end is a completely flat, perfectly rigid 2D structural unit.
Finally, Section 5, foundation of block building. Let's zoom back out and look at the big picture here. Our 2D unit is finished, and we've essentially just built the true foundation of modern block building.
By combining individual plates into these massive 2D units, shipyards are fully leveraging automation. They're using submerged arc welding for the seams, fillet welding tractors for the structural stiffeners. It's incredibly fast, the quality control is off the charts, and the whole thing happens safely under a roof. This 2D stiffened panel is the fundamental building block. Literally, without this exact process, the modern megaship simply could not exist.
So that leaves us with a pretty fascinating question to wrap up today's explainer. How do these flat 2D panels actually become a 3D ship, right? We've got the walls and the floors, but how do they bend, fold, and lock together to form super complex 3D regions, like the double bottom of a ship's hull? Well, that is exactly the engineering journey we're going to tackle next time. I hope you really enjoyed this deep dive into prefabrication. Keep learning, stay curious, and I'll see you in the next explainer.